Welcome to our first webinar on AI and the future of learning. Today, we're going to focus on assessment and how AI can help that, and on many perspectives that you'll hear from our panelists represented today. I'm pleased to represent our team with Judy, Casey, and Missy. Thanks so much. We always work as a team together in this work. And I also want to extend a big welcome to all the teachers and practitioners who may be here. We know it's been an extraordinary year for you, and we really value that you've chosen to take some time with us today. We value the work you do every day, and thanks for being part of this important conversation. I'll briefly introduce our panel, and we'll get to hear from them at more length shortly. They represent a series of perspectives, but all deeply engaged with what AI and assessment can mean today, how it can be used in products today. So Christina Heffernan will speak with assessments, a product that teachers use in their classroom to help with math homework. Janice Gober will talk from apprentice and her role as a professor at Rutgers, a science education thing. And she works with Nancy, who's a teacher who uses her product. So a really cool thing there is hearing both perspectives. And we're super pleased to have Alina with us today. She's one of the deepest experts in the field of psychometrics, the foundations of assessment, and how this technology is influencing that. And then Aaron Hahn, who I've gotten to know over the past 3 or 4 months, and really straddles these worlds of research and education, and really will help us connect what's going on to practice. So it's a fantastic panel. And I just want to let you know there's a Q&A. You can use it at any time. You can start thinking of questions, because this isn't just about hearing from this panel. This is also really about hearing from you and about starting a conversation. And we'll carry on that conversation after this hour on Twitter. We're going to have a Twitter chat. And so if you can stay, we really would value you joining us to talk some more after it ends. Okay, next slide, please. Thanks for introducing yourself, by the way, in the chat. It's great to see. The agenda is basically, I'm going to introduce a little bit of background, then the panel is going to introduce their perspectives. We'll wrap up and have a Twitter chat. Next slide, please. A lot of what we're doing today is based on some work we did in the midst of the pandemic starting last June and July. And we brought a fantastic panel of experts together to kick off a conversation about AI and the future of learning. So thanks to all the professors you see there. And I also want to begin by setting a basis for what we're talking about. So we're talking about artificial intelligence, and here's 3 ways to think about what that is. A very conventional way, you may see it in the movies, is to think about a computer embodied intelligence that could bring an extra smarts into the classroom. Another slightly more technical way to think of AI is it's something that can sense what's going on in the world. It can see patterns. It can represent what we humans think of as knowledge and actually start to make and act on plans, and also enable interaction, like when you talk to your Amazon Echo or Google Home. You're using that kind of capability. And then there's the third definition, which is my favorite, and I hope it's what we do some of today. It's a toolkit to enable us to imagine what the future of learning could be. And so it stimulates us to start thinking. And I want to, as we do that, think not just about AI, but it's sort of mirror image partner, intelligence augmentation. How is this capability extending, augmenting what we as teachers do together? So excited to do that. I just want to tell you a little bit about the report. You can read it on the web. It's published, it's open, it's free. The experts made 7 recommendations after the work on 2 days. I won't go through all of the recommendations. I want to note that today we're focusing on AI for the assessment of learning. That's number 3 that you see on the list there. We're also very concerned with the human-centered or responsible AI. How is this for the benefit of the people, the educators, the students, the parents? And also, I think we'll get into number 5, stronger policy for ethics and for equity as this technology unveils and becomes part of our lives. And of course, number 6 is super important to why we're doing this today. It's because we really believe the way to get to a better use of this technology is to involve educational policy makers and practitioners. And I just want to say our orientation to assessment, which we're going to kick off into just a second is, how do we understand what students know and can do? And particularly, how do we understand that in a way that helps us improve how we work with students, how we support them to learn? And in distance learning, this has been a real challenge that we, as teachers, I think we're used to having face-to-face contact with our students and seeing their eyes light up or not. It's a lot more challenging in remote learning. And so we've been thinking a lot about that and thinking about the future. So welcome again, and it's my real pleasure to now kick us off to introduce our panel and start with Christina, who is going to tell us about assessments. Take it away, Christina.
Thanks, Jeremy. Go to the next slide. I'm Christina Heffernan, and I'm the Executive Director of the Assessments Foundation. And I'm also the co-founder of Assessments. And my husband and the other co-founder, he is a professor at Worcester Polytechnic Institute, and he teaches AI and is also beginning to instill some AI into the system that we built. I put up some facts here, but you can look us up online and learn more. But I wanted to get into sort of assessments and how we have started to infuse some artificial intelligence into it. I will definitely speak with using sort of normal words that you all understand, because I am not the AI scientist, but I certainly listen to and talk a lot about it. So thanks. So the question of sort of where is assessments and where is the assessment in assessments and where is the artificial intelligence, I'll get to in a minute. But these images here are the 4 steps of assessments. And I will say right now that the basis of what we do is actually doesn't have much AI at all. It's just sort of a computer program that does what computers do well. So teachers come to our tool and they find from our library of content, which is mostly open educational resources. They find those and they make assignments. And then in step number 2, what you see here is the problem being shown to the student. So far, no AI. We're just connecting a problem to a student. The teacher is the one who's actually making the decisions, not some sort of artificial intelligence. It's the intelligence of the teacher. And then comes in the student. The student reads the problem and they use their intelligence to solve the problem and put the answer in. At that point, we just do matching. We just take a string on the computer that the student enters and a string on the computer that the author had put in and match them and can tell the student if they're right or wrong. So step number 3 is colored green there because that's sort of where the assessment part comes in. Teachers can now see how well their students did. And there's a row for each student and a column for each problem. But once again, there's not a lot of intelligence going on. And then the 4th step is totally on the teacher. The teacher can take that data and have conversations with their students. They tend to celebrate successes, but they also respond to problems that students are having. So that's the basic of our tool. But we have begun to infuse some of these more complex tutoring systems into it. So what you see on this screen is you see 2 problems side by side in the orange boxes. And we have actually had teachers write feedback for their own students that we're also excited to share with other teachers' students. And what you see there are 2 student supports. The one on the left is a video and the one on the right is a string of hints. And so the question that we have is, which one of these is better for whom? And what we can measure that by how well the student does on the next problem. And that's what you see in the green box. But then once we have all that information, that's when you need the AI. So that's where we program the computer to look at all the information we have about the student. Then we look at how well they did when they got either the hints or the video. And then we look at the future of the next student and figure out which one of these supports is better for whom. And that's where that AI comes in. So it's really looking at patterns of the student looking at who does better with what things. So let's go on to the next example. Because the next example, the next example leans a little bit more into the topic of today, which is assessment. That last one was more formative, like giving students feedback. How can we see how well they do and give them feedback? But this one is one of the big time sinks in assessments is when a teacher has a written response from a student. We don't grade those automatically. And so what you see in these two pictures in the orange and the green are the responses from students. So what we have done is we've used natural language processing. So that's looking at the language that students write. And we've been able to then take the way real teachers in the orange box have actually graded those responses and the actual feedback that those teachers have given. And this is where the magic happens, the AI, right? The researchers in our team have been able to look for patterns between the language in the response and the different types of feedback that teachers have given to the students. And then we have created something very similar to what you get when you do an email. In Google, they call it Google Smart Reply. And they give you 3 responses that go with what you wrote before. And so we've done that for teachers and students. And so the student has written their response, and then we give 3 types of suggested messages that will go back to the student if the teacher selects it. And then the teacher gets to pick the one that they want. And so we're really excited about how this works. But as you notice, we have the teacher in the space before those feedback actually go out to the students, because that's one of our concerns is the AI smart enough to really give a good feedback message to the student? The other concern we have is that we really are working hard to recruit teachers to fill up the teacher feedback for the AI to listen to that are diverse. And so we really want to have a corpus of teachers that is diverse. We also want to make sure that we're using the right kinds of learning tools to learn what the students are saying that are also fair. And so those are some things that are really important to us.
That's terrific, Christina. Thanks so much for both introducing how AI can really augment the intelligence that teachers bring to something like this, and also starting us on some of the fairness and equity issues. Really appreciate that. Those are things we'll want to keep talking about. And now I'm going to hand it over to Janice and Nancy to tell us about a different example. We're trying to set the stage with some examples of different systems that are in use. Take it away, Janice and Nancy.
Thanks so much. Hi, I'm Janice Gobert. I'm a professor at Rutgers, and I'm co-founder of a company called Apprentice, and we produce INKITS, Inquiry Intelligent Tutoring System for science. So we make these AI-based personalized online labs for science that automatically assess and support students' science competencies that are important to 21st century STEM and the future of work. And we currently are demonstrating efficacy of our product via research by my grad students at Rutgers Graduate School of Education. Our student platform, INKITS, and our teacher platform, Ink Blotter, that are used in concert are used both in class and remotely since the onset of COVID. Next slide, please. So our product addresses the problem that American students underperform in science compared to other countries. So currently we are ranked 18th internationally. So because of this, the new science frameworks called the Next Generation Science Standards seek to improve students' STEM skills. For example, how well they generate testable questions, carry out experiments to test these, interpret their data, warrant their claims, and write claim evidence reasoning statements. But as you know, teachers, the new frameworks also require you to assess these competencies, and this is not a trivial thing because typical multiple choice items are too coarse-grained to assess the practices of science. Lab reports take too long to grade and they're highly subjective. And students' poor writing skills can impede explaining what they know. So you have the boy there on the right hand, say with the glasses and the fairish hair. We call him Billy. He's a science genius who can't articulate what he knows in words, but he can do science inquiry really well virtually. Then you see the boy kind of towards the back in the center. He's not even doing the experiment. He's just catching the buzz in the classroom. So if a teacher relies on what students write, the boy on the right-hand side will be assessed as a false negative. So he will be assessed as not understanding science or the practices when he actually does. Whereas the boy in the back who's peering over the table of the other two students, he will be a false positive if teachers are relying on what kids write, because this boy kind of can catch the buzz in the classroom. He doesn't even have the data he's talking about, right? So our system mitigates against that. So furthermore, other typical materials for science can't provide automated, real-time personalized support, which ours does. And so due to COVID, all of these learning and assessment challenges are greatly magnified, especially for science. And so our system that's undergirded with AI has really helped teachers during COVID. So the system is called INKITS. This is supplemental online labs for physical, life, and earth science grades 4 through 12 for in-class or remote. We have 3 patents in the system. We have personalized help, automated scoring, and performance monitoring. We're the first group in the world to use machine learning for science. It's integrated with school digital tools like Google Classroom, and it's technology agnostic. So you can use iPads, Chromebooks, you could even use this on your phone. So with regard to where the AI is, next slide, please. It says efficacy at the top. Great. So with INKITS, you see on the far left, students do authentic science experiments with virtual labs. So it's like the hands-on experiment that they would do in the classroom, but they're doing it on a computer, either at home or in the classroom. All students' skills, including their writing, are automatically assessed in real time using our patented algorithms and natural language processing algorithms. So you see in the center there, the algorithms are applied to the data in real time. Students get personalized help from our virtual tutor, Rex, who's at the bottom, when the system detects they need it, because kids are very poor at knowing when they need help. So we don't have on-demand help in our system. Furthermore, our research shows that real-time help provided by Rex helps students learn these science practices and transfer them to new science topics and over long periods of time. So we've tested this up to 180 days later. Teachers get, on the far right, you'll see both real-time reports that eliminate subjective time-intensive grading, and they also provide alerts. So these alerts identify which students are struggling and how to help them. So these alerts inform teachers' instruction on who to help and how to help them. It will also allow the teacher to know if a large percentage of their class is struggling on the same practice. For example, if kids are changing too many variables at once during experimentation, they could get an alert that says 80% of your kids are struggling with this specific practice, and this is why, stop the class. So this is really a game changer for teachers to implement NGSS in real time with their kids. So our studies have shown that when teachers use this alerting dashboard, they can help twice as many students. And furthermore, the kinds of help they give kids predicts how well they're going to do the next time they do the science practice for which they were helped. So that's very robust. And I believe we have a paper that that the Digital Promise team sent around on exactly that, written by Rachel Dickler and myself and Mike Salpedro on this work. During remote use, student performance is on par or better than their in-class performance, including schools with large percentages of ELLs, English language learners. And this really indicates the potential to close the gap, the achievement gap. So in closing, before I pass it off to Nancy, I'd like to say that this is a technologically sophisticated, rigorous, and scalable solution that's based on AI to STEM instruction and achievement for in-class or remote use. It's rigorous because assessment and help are based on patented AI, and they're based on students' mouse clicks. everything they write, everything they type, every choice they make, etc., not multiple choice items. That gives a much tighter handle on the student. It's scalable because the system runs on all platforms, is fully web-based, etc. Schools buy it as a SaaS subscription, or you can trial if you have more than three or more teachers at your school who are willing to do it. And furthermore, this is economical because it doesn't require schools to purchase expensive lab equipment. It saves teachers countless hours of grading and saves administrators time on reporting. For example, if they take ESSA money or Title I money, or et cetera, from the government. So now I'd like to pass it off to Nancy Foote, who's a teacher who's been working with us for many years. Take it away, Nancy.
I have no idea how to follow that. It is absolutely amazing. I was a chemist before I was a teacher, and so I know science. I know how to teach. I've been teaching over 30 years. I will tell you that when I incorporated this into my classroom, my standardized test scores skyrocketed, and it wasn't just the lab portion of the test scores. It was across the board. People throughout the state came to ask me, what are you doing? The intention of using this was simply because I didn't have a lot of equipment. Our school was a brand new school. We were trying to do things with rubber bands and paper clips and dishwashing liquid because we didn't have a lot of supplies. Using this allowed me to do whatever I needed to do with my students. The kids at first did not like Rex. I said, well, Rex is giving you important information. Once they realized that he was there to help them, they were blown away. As for me, from a teacher standpoint, when you have 35 students in front of you, you don't know what they need, when they need it. I'm not a mind reader, I'm a teacher. But with the bladder, with the ink bladder, I was able to seem like I was a mind reader. I could go up to a student and say, remember, we have to control all our variables except the one that you're looking at, the one that you're changing. I thought my kids knew that. I taught them that. But when they put it into practice, they didn't. There were a lot of things like that I found that was very humbling for me as a teacher. When we went remote, and I'm still remote, by the way, my school is a school of choice. You can go face-to-face or remote as however you want. I have about 90 students in my science class. Going remote, I panicked. How do you teach science remotely? How do you teach a lab science remotely? My remote kids are doing fabulous with their labs. I can't wait for them to take we have a brand new science test this year in Arizona. I can't wait for them to take it because they're going to blow everybody out of the water because they're using inkets. Interestingly enough, the kids who don't show up to any other class show up only when I'm doing inkets. They won't go to math. They won't go to any other classes. They won't do anything else for me, but they will do their inkets, which I am absolutely intrigued by. Janice, there's another study for you. We can't get the kids to come to class for anything else, but they do their inkets. They seem to really enjoy it. And I come across looking like a hero because I can get the kids to come to class. It's not me though, it's inkets. I can't wait to see what their test results will be. It'll be interesting.
I'm quite sure it is you, Nancy.
I don't think so, but that's
I'm
okay.
glad to hear the ways
I'll take
in
the
which
credit.
you've partnered with some really cool technology.
I really did. Thank you.
That Janice explained for us. And now it's my pleasure to introduce another panelist, Alina, who will talk about Duolingo, really taking us out of the school context, but this is going to be important, AI and assessment in all our aspects of learning throughout our life. And Alina is just a super expert on the really foundations of assessment and AI. And so we're just so happy to have her with us today. Take it away, Alina.
Thank you, Jeremy. It's my pleasure to be here with you all. And it's my pleasure to also talk about my work on the Duolingo English test. So I will start telling you a little bit about Duolingo because it's a young company, and I want you to know that it has a really strong social mission. The Duolingo mission is to develop the best education in the world and make it universally available. And for the Duolingo English test, our mission is to use assessment technology to lower barriers and increase opportunities for English language learners everywhere. So next slide, please. So I came to this universe of EdTech after about 20 years working in education, but primarily in an assessment environment. I worked before at Educational Testing Service. I worked for ACT before. And in all of these environments, I work on it's usually called research-based innovation. And in that context, I started to experiment bringing artificial intelligence tools into assessment. And here I want to say that I'm very much in alignment with the presentation that Jeremy just had earlier. So in my work, I look at artificial intelligence as a set of tools that can help the human be more efficient and make better decisions. So this is the way I look at it, as a tool or a toolbox that you can pull out of different capabilities to make what you are looking for. So what you have here on this slide is just a little bit of my history, both in terms of education and work. From the education perspective, what is probably relevant is that I tend to be a bit geeky. So I'm gonna try my best to actually not be too geeky today. Thank you. Next slide. I want also to share with you that one of the drivers for my work in the past 20 years has been the commitment to fairness. So I started working on test equating. Some of you might be familiar with that approach. Is what makes standardized tests be comparable over time. And when someone says, I got a 36 score on the ACT, nobody is asking in 1 month, where the scorers a bit more strict or not. So test equating is what makes that possible, that standardization possible. And then I was so impressed because that gives people an opportunity to take the test pretty much a few times a year. And I thought that that's an example of fairness. Then I got very much interested in making the test adaptive and identifying who are the people who take tests and how can we be more responsive and provide an assessment that matches their ability. So that's how I work, and I publish books and papers in adaptive tests, multi-stage adaptive tests, and so on. But then most recently, I became interested in other types of assessment. Can we assess people in authentic contexts, such as when they work with each other? Can we figure out what is the best way to measure what they know and how they contribute to a problem, while each of them would bring different things to the table? So I've done quite some work on, a lot of work on assessment of collaboration. And that's also illustrated here. And now, actually, very soon, hopefully in the next few months, we will have a book on computational psychometrics that I am co-editing with my colleagues, Bob Mislevy and Jiangang Hao from ETS, where we are trying to put together this new knowledge that is being infused into psychometrics, this artificial intelligence based in new toolbox, new set of tools that can be very helpful for assessment. Next slide, please. And in this context, I have only one slide that illustrates the framework in which we see how artificial intelligence algorithms help us build, administer, and score and develop an assessment. So I would like to walk you through this because it's a conceptual framework for how we think about digital first assessments, and the Duolingo English test is the first ever digital first assessment, and it embodies all of these advantages of the algorithm while taking into account the human expertise and the subject matter experts' influence. So what is a digital first assessment? Digital first assessment is one where the test taker's experience is at the core of every decision. A digital first assessment is one that can be taken anytime, anywhere, from your own home or from another place. And in order to do that, we need to take into account tools that help us deliver such a flexible assessment. And here is where artificial intelligence helps. Also, our test in particular is extremely accessible, and comparing to all the others of this type, it's also very affordable. So the way we achieve that efficiency and that affordability is to using artificial intelligence. So let me walk you through where we've been having each of these influences. In item development, we have parts that are subject matter expert generated and some that are generated with machines. On administration, we have an adaptive administration, but we also have human proctors. On scoring, again, we have both together. And for the design and evaluation, we always have human experts. So this is a framework for assessment. And I know we will talk more about fairness and how do we ensure transparency in the panel. So I will keep those comments for later. Thank you for your attention.
Thanks so much, Alina, and for all the experience you're bringing to it. And I love the test taker at the core of every decision at the bottom. And I'm reminded how much we're starting to learn already on the National Assessment of Educational Progress. There are accommodations for students with disabilities. And already through some of the analyses people have recently done, we're learning they don't always help the students with disabilities, which is something that people didn't necessarily know. They thought they were helping. And so it's really important that we keep the students at the center in what we're trying to achieve. And so now I'm really pleased to introduce Erin Hahn, who has a new paper out, which I will post the link to in the chat, that really is just a wonderful introduction to the issues of fairness and bias as AI comes into education. So take it away, Erin, and I'll share your link.
Thanks, Jeremy. Hi, my name's Aaron. I've worked in schools for many years as both a teacher and a director of assessment and accountability, and it's great to be representing practitioners a bit on the panel today. Next slide, please. So there are a lot of systems out there that you're probably familiar with that either use AI or maybe attempt to adapt to students in other ways. Next slide. So it turns out, though, that really only a few of them are used intensively. So this is a recent study, for example, that showed that 80% of applications get used for less than 30% of their desired time. So clearly something is going wrong along the way from creating and selecting a system to actually using the system. Now, next slide, thanks. So in hopes of making that journey a little smoother, I've put together a list of 4 things to know before you go for AI and assessment. Number 1, how was it made? So it turns out that hearing about how a system was developed, I think, can really tell you a lot about how effective the system will be. So for example, how similar or different were any students involved in the development of the system to the students in your own school or district? Or were real teachers, content area experts involved? And if they were, how deeply were they involved? Next slide. Number 2, how, when, where does it get used? So schools are complex places with their own teams, meetings, instructional practices, and humans and AI really need to learn to work together to help students most effectively. So the more that a developer or a vendor has thought through the specific ways that their product will work embedded in the systems that schools already use, that's the best case for everyone. Next slide. Number 3, how does it adapt? So one way to think about intelligent systems and how they adapt is to understand whether they're getting feedback after a student finishes a whole problem and then adapting to select the next problem, or whether the system is offering feedback within problems as the student completes each steps, like the 2 systems that we've heard about earlier. And research suggests that including that kind of step level feedback can be more effective than in a system that just adapts to whether a student got the whole problem correct or incorrect. Next slide. Number 4, how does it recognize mastery? So there are many ways that software tries to understand whether a student has achieved mastery, and some are more complicated than others. What's important here is that developers are transparent about how mastery is determined and can really explain their justifications and evidence for the methods that they use. Last slide. So these are just a few quick things to know before you go. And maybe the big idea is that even if someone is using the term AI when describing their product, they still should be able to explain to schools and to districts to justify the ways it was developed, what it's actually measuring, and really what it has to offer your particular school contexts. So thank you.
So terrific. Thank you so much to all our panelists. I'll invite you now to turn on everyone's video and microphones because now we're going to invite a little discussion. And I think it's really important just to see those slides, to hear all your perspectives and also get examples of what it is we're in fact talking about. So I'm going to ask the first question. And we really want to start with just how does this technology fit into classrooms today? Where does it not fit? But, you know, should we really be talking about AI for education? Does it really fit? And let me ask Nancy to start on that first.
You know, it's been a lifesaver for me. There's no way with the numbers that I have that I could possibly be an effective teacher and give effective feedback without ingots, plain and simple, especially in a timely manner. I remember when I was going to school, waiting forever to get my lab reports back, especially when I was in college and I was waiting for those qualitative labs to find out if I got my unknowns right or not. By the time I got my reports back, it was weeks later. And that's not today's world. That's not today's society. We can't afford that. We can't afford to wait like that. Our kids need that right now. They need to be able to monitor and adjust, as we say. And that's today's world. We need it. It's got a really important place. We need to be able to assess things. We need to let them know what they're doing right and where they need to change, where they need to adapt. So it's critical.
Yeah. Anyone feel free to jump in. This is really a conversation now, and I know you all have things to add. Our question is like, how does this fit in today? Does it fit in today?
I'll say something. So I think pairing these systems that are calibrated and instrumented in a way such that it can garner all this really rich data. And then we have theories of how this data then translates into a real-time assessments for performance. So it's very rich. And then you can have a digital agent. You can have an alerting device for teachers or reports for teachers. And then we have the computational power and the computational techniques for how to analyze these data. Furthermore, when you're collecting data kind of at this volume, you can really get very deep understanding of student patterns over time. So it's really useful to use what we're learning in these systems to better them for all people, right? And make them better for real-time performance and what I call, or what Val Shute labeled, stealth assessment. So you're not waiting for this period where kids are going to get their standardized test. They're really being assessed kind of all the time. And the thing that I feel very strongly about is if you're going to make a high stakes decision, say on whether Johnny is going to go to, the best university in the country or the worst university in the country, you better make sure that that performance is representative of what Johnny can do, and that he didn't just have a bad day. So, in the UK, there was a big kerfuffle recently because kids missed their A-level exams that predicts what university they can go to. So there was a panel of experts, and I was asked to comment on this to the UK Parliament. And really, what the AI was, they aggregated the data a little bit incorrectly. And so Johnny, who should have gone to, say, Oxford, right, they aggregated his data with the classroom because they thought it would be much more valid that way. But it was kind of a silly mistake, and it got corrected. And then they were putting students in the right level of university. And so we have to, if we're going to make high stakes decisions with AI, I say we use it in stealth mode so that we get a longer kind of student performance trajectory to base that on.
Yeah. Cool. Does anyone else want to comment on the fit today and both the good,
Sure.
good and the bad of what you see, or should we move on to our next question?
I'll just add in real quick that allowing teachers to really, while this AI is doing this assessing, that involving teachers in looking at that data is also and having it be formative and not always like that story about England, Janice. I mean, of course, that's, you know, when it becomes so important and life changing, that's one thing. But really, like, just taking a breath and also saying, let's just use this to get through the next, 2 months. And I think Nancy noticed that gets the kids excited. And when they start, we get kids like your kids, Nancy, they complain about the feedback at first, but then the minute you decide to give an assignment and it doesn't have feedback, they're like, whoa, I'm now used to this. And so making it part of life and not just an assessment. And the fear of those grades is true and palpable. So
Yeah, I'm always reminded of how important it can be to get feedback quickly, good feedback quickly by a little story. Like, I just imagine people learning to shoot baskets, and the teacher says one night, go home and shoot 10 baskets, but you can't see whether they go in. And 3 days from now, I'll grade your assignment. I'll let you know which baskets went into the hoop. And who could possibly learn to shoot baskets if it took 3 days to find out if you were doing it right or wrong? And of course, every teacher would love to be there with every student and give them feedback all the time, but teachers have lives too. So if we can extend good feedback, that seems really important to me. Hey, let me ask another question, which is just taking it, we started with the practicalities of today, but I also want to open up, where could this go in the future? Because our project Circles is really, really oriented. This is going to be something emerging over 3 to 5 years at least, probably more than that. And so we want to create a vision of where it could be. So I want to invite some of your dreams, like what could be different 5 years from now if we get this right? And what do we need to worry about? Alina, would you mind kicking us off on that?
Sure, and thank you for giving me the freedom to dream and to think of what could be possible. I don't know, many of you might be familiar with Pullman's book about having these little animals as your companion and sharing information with them as you grow up as a child. So part of my vision and dream has been that artificial intelligence created tools can be a partner for teachers and parents and the child themselves in this development, and could be a companion and could provide that feedback that is needed in real time. So that is my big picture. Now, getting close to to today, obviously we are not quite there yet. And the way I would imagine we can do work, we can build towards that vision would be to have systems like the ones we heard about today, to have assessments be more attuned to practices, to have the assessment provide the results much faster and be targeted towards a better user experience, and to provide feedback and recommendations like, okay, this is my score on this assessment, what should I do next? And I'm talking more from the assessment perspective. My colleagues have been talking more from the learning perspective. So I'm looking to the point where we meet in the middle to support the learners.
Are there dreams and hopes for where we could get to? Maybe Aaron, do you have any? You haven't jumped into the panel yet, or any of you?
I think a dream is, I think the big dream is, can we find ways to assess, reliable ways to assess complex skills so we can broaden the scope of what we think of in terms of accountability systems? I think that a lot of teachers would be interested in finding, like, visualizing a pathway to moving out of the standardized assessment world and the practice testing and all the time devoted to that, and reallocate that time to learning while we also get a better understanding of our students. So dreams around actually moving forward with our standardized assessment system.
Yeah, that seems so important. I do want to point our listeners to, in the AI report that we mentioned in the beginning, there's a bit of a scenario there about writing across the curriculum. And the experts pointed this to us, but would it be possible? Any one teacher sees the writing in their class, and maybe Nancy doesn't know about each of her students as a writer, as they exist in the English class, and what beautiful work they do there. Maybe if she knew a little bit about that, it'd be possible to nurture that in the science class, for example, and bring that in. So that was one of the scenarios, is like our assessments of writing are so narrow right now compared to it being something that is a really a life skill. I know, Janice, you're trying to jump in there. Maybe others are trying to jump in. Go ahead.
Yeah, so what I wanted to say is a dream of mine is that when we can do true performance assessment, kids will really realize their talents. And the child who comes from a disenfranchised background could imagine being a scientist or engineer, could imagine being an architect, because they're like, wow, I'm actually really good at this, right? Because these kids are not necessarily getting exposure to these careers like their affluent peers, who might get exposed to these careers because their parents are informing them, et cetera, right? So that's a really, I think, a real benefit of this, that we talk about the future of work, but filling that pipeline by identifying these talented kids early on, I think is really, could be wonderful from my point of view.
I want to soon go to the questions that are coming in from our Q&A. And I just want to thank you that. But I did choose this picture back here. It's a picture I took in Yosemite, because, like, which way is the sky going? Is it going from bright to dark or dark to bright? As it turns out, the wind was kind of blowing in circles, and I alternately got rained on and got brilliant sunlight. But I want to ask you, Aaron, to just give a couple thoughts from the paper you've shared about some of the threats, the biases, the unfairnesses that we need to worry about here.
Sure. I think so. I think the first thing is to really understand and acknowledge that we don't know a lot about this in education. So most of what we've been hearing about in the news, I think, relates to criminal justice or medicine. And so when it comes to the education space, we have to acknowledge that we have to know a whole lot more about which groups were being impacted by algorithmic bias, and then how those impacts are really playing out in terms of potential harms. I think that, on the solution end of that problem, we have to be much more conscious of the data sets that we're using to train AI algorithms, and they should represent a wider range of students and have more representation from the subgroups of students for which we want to avoid bias. And I think there are then kind of community things that we should be doing around making the issues more open, like maybe evidence for ESSA could include information about how well interventions work for different populations and not treat efficacy as kind of a global idea. And also just to bring in community partners more from the start, even with AI technologies. So letting them advocate for their own positions and their own needs from the beginning of the design.
Indeed, and that's something we'll talk about if people go to the Twitter chat, is how can we get more people involved early in this? Let me go to a question that came in from our audience, and that is, could we design an AI tool that would assess students' work on something like a design project? Can we assess design thinking? That's something that a conventional multiple choice test, it just isn't going to get. Is that possible? Is it feasible?
If I may, I believe it's feasible. I was together with my previous team at ACT. We work on putting together an assessment for creative thinking for PISA. And in that context, we actually had some questions about design, and some of them were from the perspective of thinking outside of the box and trying to figure out how can you bring in new solutions or new ideas for solving a particular problem. So my short answer would be yes, we can through the design with humans. And once we do it with humans and we have sufficient data that we are able to measure that, then we can train also an AI, both for at least parts of the design and development of the tasks and interactions, but also for the scoring of those complex tasks.
Yeah, my group did some work on design thinking in designing an optimal solution for a catheter. So it was an engineering design problem. And then we actually were able to auto score that using some knowledge engineering techniques. So what we did was we focused on a couple of the processes of design. So it was design and then optimization of the catheter and how the student went about iterating on the prototype in order to make it better. And we were able to show how some students were just kind of randomly doing this, whereas others were really looking at the data they were getting and then changing the parameters to optimize until they reached the most optimal level for the design. So those are two kind of more concrete examples. It's not as open-ended as, say, creativity, but they do reflect the engineering practices of the next generation science standards.
Right, right. Yeah, design thinking is something certainly the district's digital promise works with. It's when they look at the portrait of their graduate that they want to develop over K to 12, design thinking sometimes comes to the top as one of the things they want to cultivate. And we don't have good assessments of it, so that we could is exciting. I also noticed that one of the questions is about, can we look at things like confidence and dispositions? And I'll just say, as the Circle Center can help you out with some details on this, but Aaron works with Ryan Baker, who has a very successful tool that can be calibrated with human observers helping to do this, to, for example, detect when a student is frustrated or when they're confused. So we are starting to get some insights about students' emotions and be able to sense those more early, help the teacher know when a kid may look like they're doing okay at that game, but they're actually not feeling well about it, probably. Take a guess at that. Let me ask a different question. I think it's a really great one. How do we think about this over a long period of time, not just in one course, but over years? Could we be pooling data from how a student does science in elementary school and using that to help them all the way through high school? Should we do that? Is that risky? What does the panel think about taking a long perspective?
Well, I think taking a long perspective is a really good approach, but kids love to get feedback on their work. In particular, gifted children love to get constant feedback. And so what we do is calibrate our student feedback to be a little bit more general, because sometimes when they change content areas, their inquiry skills might dip a little bit because now they're doing inquiry skills in the context of life science, which is a little bit more difficult. And we don't want them to freak out like, oh my God, why did I score lower than I did last week, right? So we calibrate those. And I think what we should do is have kind of a soft trajectory where we kind of give a sense of how are students doing so that we can identify major dips, right? And so that as a teacher, we can also identify where a student really has excelled, and that can be acknowledged, where Nancy could walk over and say, wow, I don't know what you did. Did you eat your Wheaties or whatever, but you did so well last week. That was excellent, because that gives the student kind of metacognitive knowledge as well about what they did. Hey, I wasn't listening to music at the same time, or I really just sat down and focused and did my best work, right? And that's how they're going to learn how to engage in their deepest thinking. So that's personally, as an educator, as a mother of 3 kids who've gone through school, and as a former school psychologist, that would be my best wish for how this could be used in the long run, that we should do it, but not worry about the exact number, but kind of get a sense of that we're on an upward trajectory with each child and help them when they're not, and really reward them when they, not reward them, but really acknowledge the commitment that they've made when they do well.
Anyone else want to just jump in with a quick remark and then we need to start wrapping up?
Yeah, so I would just add on to that from a different perspective and also with a lot of concern. So I'll make an idea, but I'm not sure if we should, like, I think that there's a lot of reason to be concerned about all of these things. But take that same trajectory, but use it to support teaching. We're super focused on teaching. And so if you see a certain change in a student across time, how can that inform the teaching, the knowledge of what's going on in the classroom by the teacher? It sounds a little bit scary and judgmental, but it also could really support the teaching force and getting the teaching force to make changes. And so that's sort of the same idea that Janice is talking about, but with a different lens.
Yes. And, throughout, we just want to be cognizant of the upsides, but also the risks, that dark cloud that might start coming at us, because this is challenging stuff. Well, I want to thank our panelists for just a really stimulating hour. We knew this would be the beginning and not the answer or the solution. And you did a great job of starting a conversation that will be continuing. And we're going to go now just to a few slides to wrap up. But really, just thanks so much. So thank you Missy for cutting over to the slides. So we're going to host a Twitter chat in just 3 minutes. And this is really to enable more conversation about this. So we hope you'll come. There's some instructions about how to do this there. And these instructions will be reposted in Twitter if you go. So please join us. And yes, see our website, circles.org. Circles brings together a whole bunch of National Science Foundation funded educational projects that are about the future of learning with technology. There are 2 more webinars coming up, and we hope you'll come to them. One will be about teaching, because a big shift we see is the last 10 years were a lot about personalizing for the student. And we see a big shift among our colleagues to really thinking about helping teachers. And you heard it today in today's panel. How can we help teachers and make their jobs better and help them do more for the students that they want to help? So teachers and learning environments are 2 next webinars we're going to have in this series of 3. So there's also expertise exchanges that you can become involved in. There's circle educators that you can join and be part of this conversation in an ongoing basis. And so we really welcome you in and invite you to be part of this conversation. And do we have another slide? Or is that our ending for today? Thank you. I knew we had another slide. Well, I do thank you for coming. We're really encouraged by the number of participants that have chosen to join us and by the stimulating conversation today. And like I said, this is just the beginning. We're aware of a lot of interest in this issue. We're aware of people who are policymakers, people who are school leaders, people in the technology sector, researchers are all converging on this set of issues. And we really think the way to make progress is to bring people together. So please follow us, join us, and we'll see you over in the Twitter chat. And thanks so much in closing to my team for helping us organize and pull off this event. Judy, Missy, and Casey, great job.